Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is box and whisker chart. A box and whisker chart is a statistical chart that is used to examine and summarize a range of data values. It shows the frequency distribution of the data that helps in interpreting the distribution of the data. It draws a statistical conclusion for the given data using the 5-number summary principle. The box and whisker chart is very useful to observe the mean, median, upper and lower quartiles, deviations, etc. for a huge set of data. It is used mostly used in chemical industries and weapon industries. Now let us see the features of box and whisker chart. The distinct features of box and whisker chart include: it calculates the mean, median, upper and lower quartiles and the minimum and maximum numbers for the given data set. Because we need the range, so we need to find the minimum and maximum values. Also, it calculates and displays the mean deviation, standard deviation and the quartile deviation for the given set of data. It uses an interactive legend to distinguish between two data sets by highlighting each data set with different color strips. It connects the mean and deviations of multiple sets of data by drawing a line. Also, it shows outliers, any value which is not residing within the set of the values provided. Okay, now let us see what is a 5-number summary principle. 5-number summary principle. Okay. The 5-number summary principle is used to plot data under box and whisker charts. This principle helps to provide a statistical summary for a given set of numbers. It gives information about the range, the minimum and maximum numbers, and it also gives the information about the center. Center is nothing but mean, and the spread. Spread is upper and lower quartiles for the set of the values provided. Okay, let me show you a simple illustration of box and whisker plot on the board. This is how a box and whisker chart will look like. There will be an upper box and lower box, and it will start with minimum value and maximum value. This line is meant the first quartile. We used to denote the first quartile by Q1, and this one is called median, and this line is called third quartile. We used to denote third quartile by Q3. There is another principle named as the 7-number summary, which is not used in the current implementation. On a box and whisker chart, 3 out of the 5 summary numbers are displayed by default: median, minimum and maximum number. You can also opt to display the other 2 summary numbers, upper and lower quartile, which is nothing but first and third quartile. Apart from the 5 summary numbers of the box and whisker chart allows you to display the following statistical figures on the chart. Let me list it out. Mean, mean deviation, standard deviation, quartile deviation and outliers. To execute the 5-number summary principle, we use the quartiles method. Using this method, a set of numbers is divided into 4 equal parts by 3 quartiles. 1, 2, 3 and 4. Am I right? Quartile 1, lower quartile. Quartile 2 is median. This is lower quartile, median and upper quartile. There are 2 other methods, deciles and percentiles, that are used to execute the 5-number summary, which has not been used in this implementation. Now we will look at some of the formulas that are used to plot data on a box and whisker chart. All the formulas are calculated after sorting the provided set of data in the ascending order. So please make sure that you arrange all the numbers in ascending order so that you can calculate the mean, median, first quartile and third quartile. Okay, for mean is nothing but the usual average. The formula to calculate the mean is where n is the total number of elements in the data set and x is the data points or values present in the set of data, and I is the position of values. And now let's move on to median. Median is Q2. To find the median, you will first need to arrange the given set of data in ascending order. From the smallest to the greatest number. The element that resides in the centermost position is called the median. This is easy to derive when the set of data contains an odd number of elements. You can also use the formula n plus 1 over 2 to find the position, where n is the number of elements in the given data set. But if the set of data consists of even number of elements, you will get two middle positions. Am I right? So you have to find the average of the two middle numbers residing in the middle gives the median. So finding the median for odd and even data set is slightly different. For odd, you just add one number to the total number and divide it by 2. In case if the given data set has even number of elements, you can just find the average of the two middle positions. So that's it for the median. Now let us move on to lower quartile. Lower quartile is nothing but Q1. The median divides the data into lower half and upper half. You could have seen in this figure, lower half and upper half. The lower quartile is the middle value of the lower half, that is the element between the minimum number and median. Can you follow so far? Okay, the formula to find the position of the lower quartile when there is odd number of element is, I'll just write the formula here, n plus 1 over 2. And if the given data set is even number of elements, then you can use this formula, n over 4. So these are the formulas for mean, median and lower quartile Q1. Now let's see the formula for upper quartile. Upper quartile is nothing but the middle value that resides between in the Whisker plot. You can see a maximum value and medium. In between this is called upper quartile. The formula to find the position of an upper quartile when there is odd number of elements is, so this is the formula for odd data set and this is for even data set, 3n plus 3 over 4 and 3n over 4. You can compare the formulas for lower quartile and upper quartile for your easy memorization. Okay, now let us see what is mean deviation. Mean deviation is nothing but the average of the absolute differences between each value and the mean. It gives us an idea of how spread out the set of values is from the center. The formula to calculate the mean deviation is, where n is the total number of elements in the set of data and x is the data points or values present in the set of data, and I is nothing but the position of the values in the set of data. Okay, for grouped data the formula will be slightly different. You should include the f here, f of xi minus mean by n, where f is the frequency of occurrence. The process to calculate mean deviation is, first you have to calculate the mean, that is the general mean, simple average of given set of data, and then you have to subtract the mean from each number and work out the mean average of those differences. This is how you have to calculate the mean deviation. Now let's see what is standard deviation. Standard deviation is the measure of dispersion of values in a set of data from the mean. It gives us an idea of how spread out the set of values is from the mean. Okay. The more spread apart from the data, the higher is the deviation. The less the spread apart from the data, the lower is the deviation. And the formula to calculate the standard deviation would be, it is just the square root of variance. I'll write the variance formula on the board, where n is the total number of elements in a set of data, x is the data points or the values present in the set of data, and I is as usual position of the values in the set of data. Now let's see how to calculate the standard deviation. First, you need to find the mean, that is the simple average of the given set of data, and then you subtract mean from each number and square the results, and then work out the mean average of those square differences and take the square root of the whole result. This is how we calculate the standard deviation. Now let's see what is a quartile deviation. Quartile deviation is nothing but the distance between the upper quartile and the lower quartile, which is called the interquartile range. The quartile deviation is half the distance between the two quartiles, that is half the interquartile range. It is also called as the semi-interquartile range. Now I'd like to give you the formula to calculate the quartile deviation. I'll just write the formula, Q3 minus Q1 over 2. So using all these formulas, you have to find the mean, median, median deviation, standard deviation, quartile deviation, and then you have to arrange these values and create a box and whisker chart. I'll take an example and explain you how to create a chart in our next video. So it will show the distribution. In that chart you have to notice the minimum and maximum values, and the medians will be displayed by default, whereas the upper and lower quartile values will be hidden. So to create a box and whisker chart, keep a note of the steps. You have to specify the chart type and you have to mention the dimension of the chart depending upon the value. So I'll take a very good example and explain you all these steps detailedly in our next video. Hope you're clear with the topic that we were discussing in our video. See you in the next video. Have a great time ahead. Thanks for watching.